All right, so let's start. Which one should we do first? Questions? 57. 5 tan theta plus 9, that one, equals 0. Use a calculator. 5 tan theta plus 9 equals 0. Solving this trig equation. This is number 20. Wait, did you say 20? No. 57. I'm doing the right one? Yes? Okay, 57. All right, so got my calculator handy because it says use my calculator. So I'm going to first try and isolate tangent theta by itself, right? So I'm going to move the 9 over and divide by 5. Are we okay up to that point? Tangent theta is negative 9 over 5. Okay, can you tell me right now what quadrant this angle could, what quadrant or quadrants this angle could possibly be in?
The second or fourth.
Second or fourth? So we can't be here, can't be here. Because tangent is only positive in these two quadrants, right? So the angles that we're looking for is either here or here, right? So now, tangent by definition is which coordinate over which coordinate?
Y over x.
Y over x, right? So if negative 9 over 5 is your y divided by your x, then I could have negative 9 for my y coordinate and positive 5 for my x, right? Yeah. Where would that be? I could say y is negative 9 and x is positive 5. That's one way I could look at that, right? And where would I be in this case? I'd be down here somewhere, right? So x is 5, y is negative 9. I'd be like this. Right? So we're talking about that angle right there. Yes? Yeah? Yes? Yes? I can't tell if you're saying yes. Are you saying yes? Yeah, yes? Okay, all right. All right. But negatives can float, right? A negative can be on the top or the bottom. So I could have also looked at it this way, 9 over negative 5. In that case, the y over the x, it looks like this. X is negative 5, and the y would be positive 9. I'm just trying to get you to see this maybe from a different perspective, all right? That would put us directly across at negative 5, positive 9. See, these points are directly across from each other. So all I really need to do right now is figure out what this angle is. But see, this is not a common number. Like, we don't know this on our unit circle. We don't get this number, right? So I'm going to use my calculator, and what I'm going to do is I'm going to do this. Theta must be the inverse tangent of negative 9 over 5. So do that in your calculator, inverse tangent, and let's do it in degrees. How about that? Inverse tangent of negative 9 divided by 5. Negative 60.9 degrees. Negative 60.9. That's this angle right here. Negative 60.9 degrees. That's one answer, right? But I need the angle on the other side of that, don't I? And I need all infinitely many of these, and these are directly across from one another. So can you tell me how I could get like the general solution? If theta is this, right? Theta has to be negative 60.9 degrees. That would take care of this, but I want to be able to get here, and then here, and then here. So what?
Plus pi k.
Plus pi k, right? But because we're doing this in degrees, instead of pi, what should I use? 180, right? You want to do a half rotation, right? 180, 180, 180, 180. So I'll put plus 180 degrees k. Now, did it ask for the general solutions? Oh, it only wanted the answers between, well, I told you on the homework to do both, right? Get the general, and then you get all the answers between 0 and 2 pi. Yes?
So you're adding a positive 180?
Doesn't matter. I'm adding multiples of 180, so they could be positives or negatives. right? K can be 0, 1, 2, 3, or it could be -1, -2, -3. So it doesn't really matter. This plus, the fact that it's K means I can do my rotations either this way or the other way. Am I answering your question? It doesn't look like I'm answering your question from the look on your face.
No, it's okay.
It's okay?
Hurry up for class. Okay.
Okay. If you insist. All right, do you want me to go through and get the answers between 0 and 2 pi now? You want to do that part or just leave the general? It's up to you. Yeah, okay. Are y'all like totally off the rails here or what's going on? Y'all seem discombobulated.
Yes, please.
Yeah, you want to, okay. So we want all the answers between 0 and 2 pi, right? That's what I asked you to do for the homework. This really means between 0 and 360. So if I'm going to start just picking values for k. I'm going to let k be 0, k be 1, k be 2, and just keep going and make sure I get all the answers. So if k is 0, what's my answer? -60.9, right? Is that a legitimate answer? Is that between 0 and 360 degrees? No, that's a negative number, right? So I don't want that. All right, now k is 1. So now you're going to do -60.9. You're going to add 180 degrees. And what's that? 119.1, right? 119.1. Is that within 0 to 360? Yes? Okay, now let's let k be 2. If k is 2, is that going to work or no?
Yes.
It will? Okay, so what will it be? -60.9 degrees plus 180 times 2 is 360 degrees. What does that come out to be? Someone with the calculator, just verify. 299.1. That's within 0 to 360. And now if you do the next one, it doesn't work, right? And so that's it. We've got them all. There's only 2 answers. Did that help at all? You sure?
I just did it right, yes.
Okay, do you want to see it in radians or no?
No, that's okay.
No? Yeah, the only difference in radians would be whatever your calculator gave you, this would be plus pi k. And then as you started to add your k's here, you just make sure that you never exceed 2 pi, which is about 6 point something. Yeah, 6.28. All right, what others? Yes?
So this has to be between, like any answers that are going to be valid have to be between 0 to 60.
That's what the problem in the homework said. Find the solutions on the interval 0 to 2 pi. So it's not always the case, but that's what they're asking for. All right, what others? Yes? 47. Sine of theta over 2 equals -√3 over 2. Sine of theta over 2. I'm going to write it slightly different than they wrote it there in the book. So this is number 47. Number 47 says give the general formula for all the solutions. So no calculator on this, right? You should look at this and recognize that, right? √3 over 2. It should be a common point on the unit circle. We want to know when sine of some angle is equal to that. So that means on my unit circle, sine is always the y-coordinate, right? And so this is saying where's the y-coordinate? -√3 over 2. That happens, we're here, right? There my y-coordinate is -√3 over 2. And also right here. What are those 2 angles? Did you get that far on it? Okay, how did you do the angles? Did you do degrees or radians?
Radians.
Okay, so what are those 2 angles?
7.5
Okay, and did you do,
11 pi over 6. Oh,
wait,
It's because it asked for negatives, so I did 5.
wait, ask for negative, what?
Because it says negative root 3 over 2.
Yeah, that's the y coordinate, right? The y coordinate is negative root 3 over 2 here, positive 1/2.
Oh, I see. I did it wrong. I did both sides.
Oh, you did, so you did the x coordinate.
Yeah.
Okay. Do you see how this would go then? What are these angles? What are these two angles? Y'all want to stick with radians?
4 pi over 3 and 5 pi.
So this one is 4 pi over 3. This angle here is 4 pi over 3. And this angle is what? 5 pi over 3. Are those angles directly across from one another? Can we jump from one to the other easily? No. We have to jump all the way around, right?
Yeah.
So what we said last class was we're going to write down the two different sets of solutions, infinite number of solutions for those two corresponding angles. The first one would be 4 pi over 3, 4 pi over 3 plus what? We got to, for this angle, we've got to be able to come all the way back around, right? 2 pi k. And then on the other one, we have 5 pi over 3. And we've got to come all the way back around again, 2 pi k, right? I didn't leave enough room here. Right? That's what we need. We need our angles to be this. Or sorry, I should say we need the argument, right? We need the argument to be equal to those things. So now I take this argument and I set it equal to those. So I set pi over 2, I mean not pi over 2, theta over 2 equal to that, and theta over 2 equal to this. I have all your stuff from last time. Is it all right if I just pass it out? Is that okay? Any objections? Sure? So the first one coming around was the one y'all all did together in groups at the end of class, right? Those. And then the other one is the actual homework assignment. So y'all turned in homework last time? The way I did the homework was credit, no credit. You turned it in. I kind of looked at it, okay, but it's credit, no credit. That one I actually graded, all right? So, all right, so we okay here? Not done yet. We need one more thing. We need to get theta, right? Not theta over 2.
Yeah.
So just multiply both sides of the equation by 2. And you get theta is 2 times that is 8 pi over 3 plus 2 times that is 4 pi k. And then over here, theta is 10 pi over 3 plus multiply that by 2, you get 4 pi k. Those are the general solutions to that equation. I'm open to talking about one more. Mm-hmm.
So there's no, I'm not saying. There's no radians in between 0 and 2 pi, right? For this one?
Oh, you want to see if we have an answer?
Yeah.
Okay, so yeah, I didn't do that, but I asked you on your homework to do that. So if k is 0, right, let's try and see how many of these answers are actually between 0 and 2 pi. So if k is 0, what do we get? K is 0. Then this one gives us just 8 pi over 3. Is that inside 0, 2 pi or not? No, it's too big, right? 8 over 3 is bigger than 2, so that's not going to work. What about k is 0 into this one? 10 pi over 3, does that one work? No, it's too big as well. Are y'all following that those are too big? Yes?
Wouldn't we set the whole thing equal to 3? Not equal to 3, over 3?
If you wanted to get a common denominator, you could. You don't have to. I told you to get a common denominator, right?
Yes.
I'm just showing real quick that if k is 0, that angle's too big. And if k is 0 here, it's too big.
You're not going to give him a common denominator?
Yeah, I will. You want me to? No, I will.
Oh,
Yeah. No. The question, I guess the question that came was, was let's check to see if we have any answers between 0 and 2 pi. And if you look immediately right now at k being 0, the two answers you get are already too big, right? 8 pi over 3 and 10 pi over 3 are too big. So now if I let k be 2, k be 1, it's not going to work, right? Because I'm adding 4 pi, it's getting even bigger. If I add 4 pi here, it's going to get bigger as well, right? So the only other thing you would need to check maybe is what if k is negative 1? Right? What if k is negative 1? So let's get the common denominator, just to follow the trend of what I did last class. I'm just not going to go as fast. I'm not going to go as slow as last class. I'm just going to get the common denominator. So I multiply the top and bottom of this by 3. Right? 3 on top, 3 on bottom. And then put them together. Over here, same thing. 3 on top, 3 on bottom. Better? Okay. So do we agree that if k is 0, the answer doesn't work? And if k is 1, it won't work as well. And k is 2, k is 3, it's too big, right? But we should check k is negative 1, just to make sure that going and rotating the other way doesn't give us an answer. So what would happen if k is negative 1? What if k is negative 1 right here? You get 8 pi, what? Minus 12 pi? What's 8 minus 12? Negative 4 pi over 3. Is that inside 0, 2 pi? No, right? And then if we do that here, we plug in negative 1 here for k, we get a negative 2 pi over 3. Is that inside 0, 2 pi? No. What does this mean? Inside 0, 2 pi, there's no solutions. Okay? Good question. Now, in the book, they weren't asking for that, right? No, were they? In the textbook, they said, find the general formula for all solutions. I asked you to also look in between 0 and 2 pi and get me any answers, which in this case, there aren't any. Yes?
You said you would do one more, right?
I would. I will.
Oh.
I will. What do you want?
43.
43. Root 3 minus cotangent theta equals 0. All right, I'm going to try and get the cotangent by itself. So you can do this different ways. I would just add cotangent to both sides. And so I get root 3 is cotangent theta. And I'm supposed to do this without my calculator. So do I recognize that anywhere on the unit circle? Cotangent by definition is which coordinate over which coordinate? It's the x over y, right? So let me write this backwards. Cotangent of theta is root 3, which is the same as root 3 over 1, which means that this is my x coordinate and this my y, something like that, x over y. Do you all know anywhere, does this look like somewhere on the unit circle where you would have the x over y be this? Pi over 6 here. What's the x coordinate here? Root 3 over 2, right? And the y coordinate is a half. And if you take the x and divide it by the y, you get root 3. So that works, right? Is that the only place? 7 pi over 6 over here? Right there, directly across. Right? This would be negative root 3 over 2 and then negative 1/2. So you had that, right? Okay. So that's it. Those are your two places. Now, since they're directly across from one another, I should be able to write the general solutions by just figuring out what that angle is, pi over 6, and then just jumping half rotations, half rotations, half rotations. And because my argument in here is just theta, I can just set theta equal to those answers. So theta is pi over 6, what? Plus pi k. There you go. That's it. That's your general solution. You asked about it, right?
Yes.
So did we already resolve your question, or was it finding the answers between?
Yeah.
Okay, so let's get a common denominator now. So to get a common denominator, I'll multiply the top and bottom of this by 6. So I'll get pi plus 6 pi k over 6. No questions there, or no? Do we have questions? You're good? Okay, let's just start letting k be different values and do it until we bust outside of 2 pi, right? Get too big. So if k is 1, what do you get? K is 0. Let's do k is 0. I forgot k is 0. If k is 0, you get pi over 6, right? If k is 1, you get 7 pi over 6. Okay, that's still not bigger than 2 pi, right? Because 7 divided by 6 is not quite 2. K is 2, you get 13 pi over 6. Is that bigger than 2 pi?
Yes.
Yes, 13 divided by 6 is bigger than 2. Okay, those are your only two answers. Yeah? Okay. All right, we're going to continue now. Right, more stuff today? Let's start with this problem here. We're still solving trig equations. They're just going to get a little bit uglier, right? Cosine squared theta minus sine squared theta plus sine theta equals 0. Cosine squared theta minus sine squared theta plus sine theta equals 0. All right, for these problems, let's just get the general solutions, right? Just the general answers. So that's the instructions here are to solve this equation, find the general solutions for this. All right. Yuck. So what I see here is that we kind of have a quadratic here, right? We've got sine squared in here. We've got sine here. The only real issue is that I have a cosine squared. It would be nice if everything here was sines, right? Like if everything here had a sine in it, then at least I could say they're, like the problem we did at the end of class last time. Remember where I made that substitution and I replaced something with u? Do y'all remember that? It was last class. I would like to see if I could replace my sine theta with u, but the problem is the cosine theta. So how can I address that? How can I address that? What do you mean separate?
Because they're squared.
Say again? Because they're squared? Okay, you could look at that as a difference of squares if you wanted to. You could. The problem is that we have this as well. So if the problem was just that, yeah, I would be thinking difference of squares. So this is kind of like where do we go, right? Where do we go from here? Do we have any relationships between sine and cosine where maybe we can get rid of this cosine and write it somehow in terms of sine? So do we have any relationships at all? Right now, we don't. Let's establish a relationship, all right? I want y'all to put this down here. Make sure you have this written down somewhere, very important. The Pythagorean identity. I want you to go back and think about when we talked about the unit circle. Okay, here's the unit circle. If I take some random point on this circle There's some angle here, theta, right? This point has an x and a y coordinate, right? And the big, big takeaway of this that everyone should be, like, at this point intimately familiar with is the fact that there is a relationship between x and cosine of the angle, right? Cosine of the angle always gives you the x coordinate, and then sine of the angle always gives you the y coordinate, right? So we know this. We know that x equals cosine of the angle, and we know that y is equal to sine of the angle. Everyone buy that so far? Now, if I take this picture and I draw a right triangle from this, create a right triangle. Let me draw that triangle right here. Here's theta. What is this distance right here? What is this distance right here? And what is this distance right here? So maybe we start with the easiest one. What's the hypotenuse of this triangle? How long is it? 1. Why? Yeah, because we're on the unit circle, right? So this distance is 1. By definition, if this is the unit circle, the radius is always 1, and that should be this, right? Further, this side is just the x coordinate, isn't it? Like from here to here is whatever that x value is. And what is that for us here? Cosine theta, right? This is cosine of theta. And what's the y coordinate? Sine theta, right? And now, we all know about the relationship on a right triangle between these sides, right? A squared plus b squared is c squared, right? A squared plus b squared is c squared. So according to this picture, I can write the very important Pythagorean identity down. It is, this we'll get back to, it is that when you take this side squared plus this side squared, you should get this side squared, right? Now I'm going to write it a little different because the way it always appears in formula sheets is this side squared plus this side squared is this side squared. Doesn't matter because we're adding, right? So we can write it in both forms. So I'm going to put that right here. I know that when I take sine and I square it plus cosine and I square it, I should get 1 squared, which is 1. This identity, known as the Pythagorean identity, is the most important identity in pre-cal in this class. Everybody coming out of this class needs to know this like 1 plus 1 is 2. Sine squared theta plus cosine squared theta is 1. It comes from this very nice picture. Any questions about this picture? Where it comes from here? What's great about this formula or identity is that it's an equation that connects sine squared and cosine squared together, right, through some relationship. And when we get back to this problem over here, what I can do is I can take this cosine squared theta, right? This is the part that's kind of like, I wish this had sines in it. And I can use this right here to help me turn this into something with sines in it. So watch me do it. What I'm going to do is take this Pythagorean identity right here. I'm going to take this. If I asked you to solve this for cosine squared, what would you do? If I said, hey, get cosine squared by itself, what would you do? You'd move the sine squared to the other side, wouldn't you? So this formula is the same as this. Do you agree that that's equivalent? Like if this is true, then this is true, right? Well, look, this gives me a formula for cosine squared theta in terms of sine squared. Right? So I'm going to come over here and I'm going to replace cosine squared theta with 1 minus sine squared theta. So this becomes, I'll do it in red so you know what I'm replacing. This is 1 minus sine squared theta, right? Then I still had here minus sine squared theta, and then plus sine theta equals 0, right? That's, I shouldn't have done it that way. This right here became these two, right? That became this. Now, do you see that pretty much we got rid of the cosines now? All we have is stuff with sines in it, yeah? How many sine squareds do you see there? 2 of them, right? So I'm going to put them together. Put these two together. I'm going to start to put this more in like a descending order. -2 sine squared theta plus sine theta plus 1 equals 0. So I put these two guys together to this. I still had this sine theta. And then this 1 that was out here, I just put it here, and then it equals 0. Now, does that look more like a quadratic to you? Right? Like we did last class, if you kind of squint your eyes, if you act like this is like the good old-fashioned like x, this almost looks like we have like -2x squared plus x plus 1, right? Kind of looks like a quadratic. Now, I don't like the negative. You see the negative in front of the 2? I don't like it. I'm afraid it's going to mess you up. So what I'm going to do right now is I'm going to multiply both sides of this equation by -1. Multiply the left side by -1 and the right side by -1. All it's going to do is change the signs. It becomes 2 sine squared theta minus sine theta minus 1 equals 0. Is that legal? Is that a fair move for you? Multiplying both sides by -1? Yeah? Okay. Now I'm going to make a substitution here just to help you see this. Everywhere that I see a sine theta, I'm going to replace it with u. Everywhere I see sine theta, replace it with u. What's the new equation become? What do we have? What's my new equation? 2u squared? Yeah, keep going. Minus u minus 1 equals 0. Now that is a quadratic, which I hope you're semi-comfortable with in terms of factoring. If you can't factor, you have to use quadratic formula, right? But hopefully this is factorable. Is it? Should be. Let's see. I would need 2u here. I would need a u here. I need to get a -1 in the middle, so I'm putting -1 here, plus 1 here. Let's just pause for a second and just like grasp what we've just done. We started with some equation. I wanted to know what values of theta make this true, right? And we looked at it and said, well, I'm not quite sure how to handle this. It would